Hello my dear students, good afternoon, and now we will discuss about variation of atomic radius. Actually, periodic properties is our topic. Periodic properties. What is periodicity? I was given in previous. Periodicity means the property which repeats in particular elements for every regular intervals. Actually, you remember, I think so. First period consists of 2 elements and second and third consist of 8 elements and fourth and fifth consist of 18 elements and sixth consist of 32 and seventh also can fill with 32 but which is incomplete. 1, 2, 3, 4, 5, 6, 7 periods actually. Do you remember? The first period which starts with 1s and these two 2s and 3s and here 4s and here 5s starts with what? Subshell, means electrons filling in those what orbitals. I am saying here in hydrogen electron enter into 1s. You remember? And here lithium electron enter into 2s and here sodium 3s. For potassium 4s last electron. Potassium configuration you can check, and 5s, and then here 6s like that and here 7s like that. So for every regular intervals they have same number of electrons. If you take 1A group elements, they have same number of electrons. So for every regular intervals the properties will repeat. Means after 2 elements the properties will repeat, and after 8 elements the properties will repeat, and again after 8 elements the properties will repeat, after 18 elements, after 32 elements the properties will repeat. Those properties which repeats in elements for every regular intervals are called periodic properties. That repetition is called periodicity. In that first periodic property we started in previous, that is atomic radius. Atomic radius means the distance from nucleus to outermost shell. That is called actually radius. What radius? What radius? Atomic radius actually. But atomic radius, different radius I was given. Between two atoms, if covalent bond is there, covalent radius you will have like that. Given or not? So actually those types of atomic radius video I will send, okay, for new students. And variation of atomic radius, how happens in groups and periods, let's see today. Okay. So atomic radius means distance from nucleus to outermost shell is a distance. So in group, how atomic radius vary? Can you say in group how atomic radius varies? See, in group, this is the 1A group. See, as you are going down, the shell increasing. See, first A group if you see, first period consists of first orbit, and here second orbit, here third orbit, here fourth orbit, and fifth orbit, sixth orbit, seventh orbit. Means as going down, see, first orbit if you see, what element you have? Hydrogen. In hydrogen what orbital you have? 1s. And second, sorry, not orbit, second period, first period and second period. Second period if you see here, what you have? Lithium. For lithium what is the configuration? It's 2s. Correct? And third period if you see, here sodium you have, that means 3s you have. And fourth period if you see, and here potassium you have, that is 4s. Last electron I am saying, because why sir you are saying last only? Because radius means I told distance from nucleus to outermost shell. If you see lithium configuration 1s2 and 2s1. Correct? So last electron enters into 2s. So distance for lithium means distance what you have to consider? 2 shells we have to consider. Nucleus to this second. Here 3 shells you have to consider this one. For potassium 4 shells you have to consider like this. Correct? Because potassium configuration if you see 1s2, 2s2, 2p6, 3s2, 3p6 and 4s1 means last electron you have in 4s. Correct now? So for potassium, what distance you have to consider from nucleus to fourth shell you have to consider. And fifth period, like that, if you see potassium, rubidium you have to consider, cesium you have to consider. So here 5s and here 6s, like that. So why you are saying this stupid information? No, it's not a stupid information. This is absolutely important information. So what is that? As you are going down, the new shells are adding. New shells are adding. So first here you have only one shell for hydrogen. But in second period 2 shells you have. Third period 3 shells. Fourth period 4 shells. Very clear. Fifth period 5 shells. You don't have a place here. I don't have a place here, so that's why I am not writing. So as you are going down, new shells increasing. So that means as going down, the distance between nucleus to outermost shell increasing. I said correct or wrong? So what happens therefore as you are going down? Write down this, have a screenshot and write down. So as you are going down, okay, so as you are going down, distance increasing from nucleus to outermost shell. Therefore, in generally you can say in group, top to in group. What's that? In group from top to bottom, atomic radius increases. Can I say like this? In any group, as group means vertical columns or not? So in group from top to bottom, atomic radius increases. This is the important thing for us, because as you are going down, new shells are increasing. What is the reason? Because as going down, new shells increasing. Okay, electron enters into new shell as going down. Difference I shown or not in previous? For potassium 4s, for rubidium 5s, the last electron, which is called differentiating electron, enters into last. Okay, of course, here in D block there is no much variation, and that reasons I'll tell you later. And now we will discuss about what happens this atomic radius in period. Okay, that we have to discuss. So now atomic radius in period. Okay, so what happens in period from left to right, because period means 7 periods, left to right. Horizontal rows are called periods, vertical columns are groups. I was given or not in previous? Like that you have to remember. So in period from left to right, what happens? Atomic radius decreases. What happens? Decreases. Why, sir? If you see, suppose here lithium and beryllium, boron, carbon, nitrogen, oxygen, fluorine and neon, if you see these are belongs to what period actually? Second period elements. I written here. Second period elements. Atomic radius left to right in period, what happens? Decreases. See, if you see these configurations, atomic number 3, 4, 5, 6, 7, 8, 9 and 10 are the atomic numbers. Lithium configuration, if you see, it's a 1s2, 2s1. Beryllium, if you see, 2s2. 1s2 is there, continuation is 2s2. Boron is 2s2, 2p1. Carbon is 2s2, 2p2. Sir, 1s is there, along with that I am not writing. What I am saying here, electron enters into same shell, if you observed or not, 2s, second shell. So electrons increasing in a same shell. Okay, so that's happening actually. Here 2s2, 2p3. Configurations you see I was given also in previous. So nitrogen 2s2, 2p3. Oxygen 2s2, 2p4 and fluorine 2s2, 2p5 and neon 2s2, 2p6 actually. Understood clearly? So here what I am trying to tell you is, in period from left to right, number of electrons increases. I repeat, in period from left to right, electrons increasing in same shell. Certainly, what happens? Nuclear attraction increases. Certainly, outermost electrons are somewhat closer to nucleus as going from left to right. Certainly, outermost electrons are coming closer because number of electrons increasing, nuclear charge increasing. Certainly, distance decreases. So, therefore, from left to right, atomic radius decreases. I repeat, in period from left to right, in period from left to right, what happens? Number of electrons increases in same shell. See, electrons increased in second orbit or not, second shell or not. Okay, number of electrons increased in second shell. Okay, so left to right increasing. Here 1 electron is there in second shell. Here beryllium 2 electrons. Boron 3, 4, 5, 6, 7, 8. Octet configuration I told you, 8 electrons are there in outermost shell. So as if you observe, as you are going from left to right, number of electrons in same shell increasing. Certainly nuclear attraction increases, which results decrease in radius because attracting towards nucleus. So in period from left to right, number of electrons increase in same shell. So which results increase in nuclear attraction. Increase in what? Nuclear attractions. So which results? Nuclear attraction increases means attracting towards nucleus. So distance decreases. So what I said here, in period from left to right, atomic radius decreases, and this is the reason behind it. So please note it down everyone. So what happens? Atomic radius in periods. Okay. So actually we have to discuss, please have a screenshot this one. So this is 2s1 and it is second period elements. Have a screenshot. Okay. Now we will discuss about atomic radius in transition elements or D block elements and F block elements. There one small concept we have to discuss. Okay. So what is that? Let's see. So what I said now, atomic radius in transition elements. Transition elements. Transition elements present in what? D block elements. Except zinc, cadmium, mercury, the remaining are transition elements. Transition elements have empty d orbitals actually. Okay. So D block elements are called transition elements, but except zinc, cadmium and mercury. Understanding, sir, everyone? So here we have to discuss about atomic radius in transition elements. So even left to right or top to bottom, in transition elements, atomic radius is almost same. Atomic radius is almost same, either from left to right or top to bottom. Slightly increase top to bottom, but not effectively. Very less increase. And left to right actually must decrease, but there is no much decrease. They have almost similar radius actually. So that's why transition elements have similar properties I told. Do you remember? So that is the reason here. Okay. In transition elements, atomic radius is almost same. That is due to one concept, that is Lanthanide contraction. Lanthanide contraction. This is the most important thing for us today. To understand this Lanthanide contraction, you must know few things like contraction. Contraction means what? Decreasing size. And to understand lanthanide contraction, you must understand one more, that is a shielding effect or screening effect. What is that? Shielding effect or screening. What is that? Screening effect. These things you have to understand first. Screening effect means actually outermost electrons. Okay, outermost electrons, these are the penultimate electrons, and here you have some nucleus. So these outermost electrons actually attracting towards nucleus, because outermost electrons means negative and nucleus means positive. So certainly these outermost electrons will try to come towards nucleus, but these inner electrons are there, no, which are called penultimate electrons. So these inner shell electrons are protecting them to avoid what? Nuclear attractions. Okay, what is the shielding effect? Now you can understand. The protection of outermost electrons towards nucleus by whom? By inner shell electrons is called shielding effect. Understanding, sir? Suppose this blue color marker is my daughter, and this is me, black color, and here ice cream parlor is there. My face is ice cream parlor, suppose. This girl is coming towards, attracting towards ice cream. So I am protecting. This protection of ability of this Giri sir, this black color is Giri sir. Understanding? Actually I am black, that's why. So here this black color marker is protecting this girl from ice cream. So what happened? Screened, shielded. What is shielded? Understood? So shielding means understood now. So this girl is attracting towards ice cream, but I was protected. So don't eat ice cream, it's not good. Now is our COVID-19 also there. Okay, so don't move towards ice cream, I am saying. So this is called protection. So what happening here? Same story happening. This is nucleus, and here these are the orbits. Okay, suppose this is outermost and this is innermost. Innermost, or what I said in previous, penultimate. Outermost, penultimate. See, outermost electron actually attracting towards nucleus, but this penultimate electron protecting. In penultimate shell, who is there? Me. In outermost, who is there? My daughter. Who is this nucleus? Ice cream parlor. Okay, attracting and protecting. So this is called, this protection of penultimate electrons. To whom? Outermost electrons. Protecting of outermost electrons from nuclear attractions by inner core electrons is called shielding effect. I will write definition. The protection ability of inner core electrons, the protection ability of inner core electrons towards nucleus. Okay, but actually who is attracting towards nuclear attraction? Nuclear attraction of outermost electron. So this is about what? Shielding effect, or the protection of outermost electrons from the nuclear attraction by inner core electrons or by penultimate electrons is called shielding effect. The protection of outermost electrons by nuclear attraction. Okay, so from nuclear attraction by penultimate shell, penultimate electrons is called what? That is called shielding effect or screening effect. Okay, so hope you written this. So otherwise I will write like this: the protection of outermost outermost electrons from nuclear attraction. Who are protecting? By inner core electrons. Inner core electrons means what? Inner core electrons. Okay, inner core electrons means penultimate electrons. Penultimate electrons is called shielding effect. So the protection of outermost electrons from nuclear attraction by inner core electrons is called what that is called? Shielding effect. Shielding effect. This is very important. Please write down. So due to screening effect, outermost electrons actually protected. So have a screenshot everyone. Okay. So who is more protecting? That I will tell you now. What is screening understood? Screening means protection. Who is giving protection? Inner core electrons. Who are getting protected? Outermost electrons. From whom? Nuclear attractions. Clear? So as I give an example, if you remember, yes, you can understand. So you people, okay, you all brilliant students are protected by your parents. So who are shielding you? Your parents are shielding you. Your parents protecting you from some other attractions. Okay, that is what shielding effect here. I am protecting my children like that. This is called shielding effect. Here, who is protecting outermost electrons? So no, sorry. Who is protecting inner core electrons? Okay. So what is the shielding effect? You have idea now. So what is the next? Order of shielding effect means who protects more. That is very important. So the order of protection is S has more protection ability than P, than D, than F. Okay, these are the inner core subshells. Because if inner subshells are S, they are protecting more. So D and F are poorly shielding. Who are poorly shielding? If the inner subshells are D and F, they are not protecting properly. If the inner subshells are not protecting properly, then outer electrons attracts towards the nucleus, certainly distance decrease. Correct or not? If I am not protecting properly, what happens? This girl will come towards ice cream. So that means distance decreasing or not between ice cream and this girl. Because in middle I am not protecting properly. I became old, so I am not protecting properly. Certainly this girl will come towards the nucleus. Nucleus means ice cream here. What I am saying, understanding? Who has great protection ability? What subshells? These are inner subshells actually. If inner subshells are S, they are strongly protecting outermost electrons. Who are strongly protecting? If the inner subshells are S or P, they are protecting more. Okay? Why, sir? Because S orbital is more spherical. It has electron density. It has a screening in all the directions actually. So protection is more. But this P and D and F are very much one particular direction orbitals they are. Certainly they cannot protect much properly. So who protects more strongly? If they are inner subshells, means S subshell, if the inner subshell, that protects more, strongly that protects more. Understanding? So what is a shielding effect? We have an order of shielding effect. I was given S subshell, if there is as an inner subshell, that protects more stronger. So order of shielding effect, S greater than, P greater than, D greater than F. This is order of shielding effect. So shielding effect you have, and which shields poorly I was given now. So that if you understand what is a shielding effect, now you can understand what is Lanthanide contraction, and due to Lanthanide contraction, why atomic radius is almost similar in transition elements also you can understand. So this is very important. Please note it down. Order of shielding effect everyone by having screenshot. So Lanthanide contraction I will tell you now. Okay. So here I was given what is the screening effect and who shields much. So now we have to understand what is a lanthanide contraction. What we have to discuss now? Lanthanide contraction means what? Okay. So lanthanide contraction means the decrease in, contraction means decrease, I told or not? The decrease in atomic radius due to pore shielding effect of inner D and F subshells. Inner D and F subshells in what? Transition elements. In transition elements or in F block elements also is called lanthanide contraction. Write down this definition, everyone, very important. What is the definition here I was given? Lanthanide contraction. So that explanation I will give you, no doubt, but definition you write down first. Lanthanide contraction means the decrease in atomic radius due to pore shielding effect of inner D and F subshells in transition elements. So certainly, if the inner subshells are D and F, as I said in previous, they cannot shield much. Certainly, what happens? The outermost electrons attract towards nucleus. Certainly, what happens? Radius decreases. As I said in previous, here nucleus, ice cream parlor, here is there. And the inner subshells are N-1 D, and here Ns you have. These what happen? N-1 DF subshells or N-1 D subshells and N-2 F subshells are present as penultimate subshells, and these are pore. Penultimate D and F are poorly shielding. Certainly, these Ns electrons will attract towards nucleus. Certainly, distance what happen? Decreases. That decrease is called contraction actually. Sir, how you are saying these N-1 D subshells are present in transition elements? You know, what is the electronic configuration of D block? Tell me. D block elements electronic configuration. You remember N-1, okay, N-1 D 1 to 10 and Ns2. This is the configuration, right? Or Ns2, N-1 D 1 to 10. If it is 4s and this is 3D, that means 4 is outermost, I said, and 3D is the penultimate. Correct or not? So, if you see the electronic configuration of this D block, the outermost is Ns. Okay? And the innermost is N-1 D 1 to 10. So D subshells are order of shielding I was given. What is order of shielding I was given in previous? S greater than, P greater than, D greater than F I was given or not? So these are poorly shielding or not, D and F? Certainly these Ns electrons will attract towards nucleus. If they are attracting towards nucleus, distance what happened? Decrease. That decrease in radius is called, what it is called? Lanthanide contraction. Suppose if you take some example like some chromium, like that, chromium, it is 1s2, 2s2, 2p6 and 3s2, 3p6 and actually 4s1, 3d5. But you can write as 3d5, 4s1. I told you, do you remember or not? This 4s is even outermost, but 4s is less energetic than 3d. That's why first we are filling 4s and then 3d. But I told you that very clearly, even 3d is more energetic. This is inner subshell. Correct? Outer subshell is 4s. Even it is less energetic than 3d, but number 4. So this 4s is belongs to fourth shell and 3d belongs to third shell. Correct or not? So 3d will be a particular inner subshell and 4s is the outer subshell. So actually that is only the reason. Outermost electron only you have to remove for formation of ions. That also I mentioned in previous. Do you remember? In ions formation I told you. Given also, second time also I sent that video. So here what I am trying to tell you is, this 4s is outer actually. This 3d is inner subshell. So p subshells are poorly shielded. Certainly this 4s electrons coming towards nucleus, which results decrease in atomic radius. Reason understood? What is the reason behind the decrease in atomic radius? Due to poor shielding effect of inner d and f subshells. So what is lanthanide contraction? I was given clearly. Lanthanide contraction is the decrease in atomic radius due to poor shielding effect of inner d and f subshells. So why transition elements have almost similar radius understood? Due to lanthanide contraction. Why that contraction happened understood? Due to poor shielding effect of inner d and f subshells. Why contraction happened? Due to poor shielding effect. Due to poor shielding effect of inner d and f subshells. So what is our final conclusion? Due to poor shielding effect of inner d and f subshells in d block elements as well as f block elements, the atomic radius will decrease. That decrease in atomic radius is called lanthanide contraction. Lanthanide contraction reason: poor shielding effect of inner d and f subshells. Because in transition elements or in d block elements or in f block elements, the inner subshells are d and f, which causes poor shielding. So outermost electrons attract towards nucleus, certainly radius decreases. That decrease in radius is called poor shielding effect. So till now, atomic radius, how varies in group and period we discussed, and tomorrow in our next class we will discuss about ionization potential, that is the next periodic property. Hope you understood. Still, if you have any doubts, please ask me. I am ready to explain. Thank you very much.